Good morning. How's everyone doing? Good. Good news is we don't have an exam today, but we do have one on Thursday, right? So what I thought I'd do today is go through some of the major questions, and I have seen the exam, and they finished it up, I think, last night. I had the option, there's two versions, one with one free response question, which means they just ask you, you fill it in, one that's completely multiple choice. I guess I still have time to change it, but so your input's invaluable. I decided to go with the one that's all multiple choice. Easier for me to grade, and it's what I told you you'd be getting, so there was a couple professors who wanted a open response type. And I agree, those are good practice for when you get into calculus, because a lot of them will be. But even I've taught the calculus for engineering, I teach the brief calc. There's a portion of the test that is multiple choice. There's a few free response where you have to show your work. But I think you do that enough with the homework, so you don't always have to test. So again, the test will be all multiple choice then, unless there's any dissenting voices. No. Okay, so we'll go with that. It's 20 questions, and I do have in Canvas some of the questions, some videos for some of the questions. I'll go back over those, but there was a few that I was looking that I wanted to go over, and I noticed there's a few of those that I chose that already have videos, so I'll maybe either put them off till the end, so let's see how many we can get through. Does anyone coming this morning, did you have any questions that you worked through or whatever? Did anyone have any particular numbers that they want to work through? No? Okay, so your first chance. Not that you can't get another chance. So I'll start with this one because this is the box problem. You did the one above it, 33, I think, or 31. You've done it enough. It's got, again, you're subtracting off two x's. So this one will be very similar, but it's a little different. So I wanted to show you, kind of go through that application. But again, be able to do this sort of box problem one, but here is a different version. So we've got a sheet of paper or cardboard, whatever it is, 15 inches by 12 inches. In this one, we're going to just cut out one square, one corner, because when we fold it up, we're putting it against the wall or something to make a box for toys or whatever we put in there, So the key part is we fold up the two sides, and one of the questions we're going to have is, how do we calculate the volume of this box? Right? So we want the volume. And this is being recorded as well, so you'll be able to go back over this later. Those who aren't here will be able to pick it up a little bit later as well. So, right, it's going to be what? Length times width times the height. So that gives us volume. And of course, we want to figure out, we want the thing that will hold the most, so what gives us the biggest volume. And as we see here, the length of the cut is going to be square, but we kind of just say that's x, that's some unknown amount. And then the goal is, what's the amount that's going to give us the biggest volume, right? So how would we come up? So if this side is 15 inches, right, 15 inches, what is this side going to be? What is the dimensions of, I guess I'll call that the length, right? We've cut this part out, and this is the part that's left, right? It was 15 inches. How much did we subtract from it? X, 1x this time, not 2x. We didn't cut from both sides, so it's just a 1x. So that's going to be our length. And then our width comes from over here, right? It was 12. we cut this part off. So this part now is 12 minus x. Okay, you see how that works? And then what's the height going to be? So we fold it up. Isn't the height coming directly from the amount of the cut? Right, cool. So our volume is, and it doesn't matter the order you put it in, but 15 minus x times 12 minus x times x. Okay, so be able to get a problem like this. It'll be one or the other, one of these box problems, be able to see how much the cut is and be able to get the volume. And then in the activity, how did we find out the maximum volume? We had to graph that, right? I mean, you could start plugging in different values, but you're not going to get exactly. Now, it's a multiple choice test. You don't have a graphing calculator. If that's the question, what's the max? You could start plugging them in, see which one gives you the biggest number, right? So that's the advantage of having a multiple choice. But otherwise, we would graph this. And if you've done the activity, hopefully you have, the graph looks something like this. And the max is the top of the hill. So we graph it, find that, and the y value is the maximum. The x value is the amount of the cut, because that's what that is. And then this y value here is maximum volume. Okay. Questions on that one? Yes, sir.
How come the graph is not? How come it's not like it's to the power of 3?
It's to the power of 3. So yeah, if we got the full graph, you'd see another part going down like this, I think. So, yeah. So it's a cubic, and so it's got two parts. One of them is like for a negative cut, which we can't do. So a lot of times in math, there's only a part of it that fits the real world situation, and as you cut over. So yeah, that's why it's got this sort of funky shape. It's not a quadratic. That's what's not symmetric. Good noticing that. We good on that? All right. And again, if you got some that were, as we go through this, that you feel that you remember that you wanted to see, we can do that. Let me clear that out. Let's see. Oh, here it is. Got too many little things. So we got 32. Next on my list, I had number 10. And it's not necessarily the order, but I did, as I looked through the test, I looked at some that I thought would be maybe more problematic than others. And so I wanted to make sure we got to those. Okay. So a question like this, be able to think about this. So a bucket is filled with water to the 7-gallon mark. So we got 7 gallons. The bucket springs a leak, and water begins draining at a constant rate of 3/8 gallon per minute. Okay. Let's come back here. So the pieces of information we're given is start at 7, it's draining constant rate 3/8. Write a function that determines the number of gallons of water in the bucket in terms of the number of minutes t the water has been draining. And again, it's multiple choice. You just have to recognize the correct one. But out of these two things, what kind of equation are we going to come up with? What kind of function? Cubic, quadratic, linear. Are those three? Linear, right? Because it's constant rate, right? Anything is a constant rate, start thinking linear. What does a linear equation look like? Excellent. Y equals mx plus b. So we've got the y, we've got the x. All we've got to do is figure out which one of these numbers is the m, which one's the b. So m is our slope. Slope is a y over x, it's a rate of change. Which one of those numbers is a rate? 3/8. You see that constant rate. And again, that's really the whole theme of calculus is rates. So that's what we focus here. So 3/8 is our rate of change. It's our slope. Now, is it positive or is it negative? Are we gaining water or losing water? We're losing water. So it's, yeah, so it's sometimes hard. I guess if we were seeing how, if it was falling into a bucket and we were measuring how much that bucket gets filled up, then it might be positive. But for our situation, we're losing it. So we're going to say our equation is y minus 3/8. So we're losing 3 gallons every 8 minutes. Those would be the units. You don't have to have that part. And then what is the b? That's the y-intercept, right? What's the significance of the y-intercept? 7, because that's a starting value. If x was 0, it's what we started with. We started with 7. Okay, so that's kind of getting you just to think in terms of rates, and that's a positive 7, because we started with positive 7 gallons, and that's it. Okay? But I didn't use the right variables, so that's how I would do it, because I think in terms of x and y's, and then I said, oh wait, they don't want x and y's, they want n's and x. So just make sure you choose the right one. I don't think they're going, so let's see, T is the water been draining, what is this? The gallons of water in the bucket, that's the y actually, right? That's the amount of water in there, and x in this time was time. So they might put the variables backwards, so just be careful. So, do know that part. They could have the n and t reversed, and that's not how they've set it up. So again, remember, this is the one you have to read through and follow the instructions there. Is the change in n proportional to the change in t? And I'll help you with that one. If this is not 0, they're not proportional. The changes are not proportional. Wait, did I get that right? No, I got it backwards. Sorry. The changes are always proportional, right? Because the slope is always the slope. It's a constant rate of change. So yes, the changes are proportional relationship. The relationship is 3 to 8, right? And literally negative 3 to 8. That's always going to be the case. If you know the change in y, you know the change in x. Okay, it's going to be constant. However, the variables themselves, and again they kind of switch. Now they've got d that have drained, which should have been anyway. I don't know. D is not going to be proportional to t. Well, actually, n is not going to be proportional to t because it doesn't start at 0. Okay, so they're not proportional. They're changing it there. Don't worry about that question. Does that sound good? Okay, so let me take that out. So that gives us, that was number 10. I have 8 and 36 and 35 listed to do, but we've got videos of them. So I basically did the same thing. Maybe I did it even better. I don't know, because I was sitting at home and was comfortable. And anyway, those are in the videos. In fact, let me at this time, I'll come back to this, but where you want to go is in Canvas, go to Exam 1 Preparation. Hopefully you've been here before. This is the review we're going over. There's an answer key to it, and it provides some written explanations. There were some additional problems. I didn't see any reason to go through those, so if you don't want to go over those, if you haven't, don't worry about those. If you want to, it's good, but I wouldn't worry about them. There's no points. And then there's all these videos for these questions that refer back to, they're done of this review. Okay, and you'll see question 8's there. You kind of skip around. And I did this one actually at the end because this was for the final exam. We'll see, we might be able to reuse some of these, but there's some of these, so there's 36 and 35. There's some other questions if you had that are here as well. Okay, so that's a good place as you're reviewing. And I even show you how to use the calculator in some of these. So, yeah. The other one then, so I've got 1, 2, 3, 4, 5 more to do. And then we can see if there's any more questions, or if you want time to work on things, we can do that. You let me know what you need and we'll do our best. It is a paper version. It's like 8 pages, about 2 questions per page. There's an answer key on the back where you'll record them, and actually I'm going to have you just kind of tear that off because that makes it easier for me to grade. But you'll just record your choices, and it's pretty straightforward. But it's so make sure you bring a graphing calculator with you if you want to use it, because we won't be using our computers. Just the or a standard calculator, whichever you want to use, but bring your technology with you. Pen, pencil, you can use color. If you want some scratch paper, again, they're kind of spread out, so there should be room to work on it, but if you want some scratch paper, bring some of that. Okay, so for this, I'm going to focus on 2 of these. So I'm going to look at C. Let's see. So let's take a look at doing C and E. Not that, the others are a little more straightforward. This one with the inverse, we could take a look, but it's you don't have to worry. So this is a composition of function, reading it off of a graph. Okay. Notice we have two graphs here, 2 functions. One's g of x, and the red one is r of x. Okay. So we're asked to evaluate r of g of 4.5. So what does that mean? Well, it means we first go ahead and find what is g of 4.5. So how do we do that? Well, we go to where x is 4.5, which is about right there. We go up until we hit the g function. And we hit it there, and then we read the y value, which is 6. That makes sense? So what we've done is this equals 6, so are we done? No, we got one more step. The next step is, that's the inside part, so now what we really have is r of 6. Now, doesn't that feel kind of strange? Because you're saying, isn't 6 a y value, and now we're putting it in as if it were an x value? Yes, it's strange, but that's how these things work. It's, in fact, I've got colleagues that says you really shouldn't put compositions like these on the same graph because the y becomes an x, and so you're probably dealing with different stuff. But we'll say x and y are maybe the same type of quantity. I don't know. I can't even think of a situation where that would work. But anyway, this is how we would do it. There's also one in the practice or where you have actually 2 separate graphs, which is technically a little bit better. But we can still do this, can't we? So now what is r of 6? Let's change colors because we're doing a different one. We come to where x is 6, right? Because that's the input. We go up till we hit the r graph, which is right there. And then we read the y value. So our final answer is 1. Okay, so just watch for that. Again, multiple choice is not necessarily easy because they have these things, the wrong answers, they call them distractors. They mean they're chosen very carefully, and sometimes, especially if you're like me and you're dyslexic, you'll know the right answer, you'll do that, and then you go look at the distractors, and then you'll switch them because that's just how your brain works. That's how my brain works. So I have a harder time sometimes with multiple choice, so that's why I always go down and write it down, and then I got to be careful I chose the right one that I wanted. But again, on the paper, if you'll at least you know, if you'll write something, we've got some evidence and stuff, but I'll work with you on that. But just be careful, choose your answers carefully. But again, you'll be able to recognize it. So E will do the same thing, and notice, but it's in a different order, right? Which one do we look up first? We go to the R function first. So we're going to go to the red. So we're putting in -2, which is over here. We've got to go down to the red function, which is there. And we read the Y value, which is -1. So this becomes now G of -1. And notice again, a Y value is getting plugged in as if it were an X value. So what is G of -1? We come to -1. We go down to the G graph. And we're still at -1, right? We come over, we hit the same Y value in a different place, but the answer's still -1. So it's kind of, okay, but it's a double lookup, looking it up 2 times. Look it up on the one function, you get a Y value, it becomes the X value. Take that X value, look up the next Y value, and that's how it works. Is that okay? Yes?
How come the first for C you found the G graph first, and for E you found the Y graph first?
Very good. Anyone tell us why? Think of PEMDAS, right? What's the order of operations? Parentheses always get done first. So we go to the parentheses, we do what's inside. So part of this is, yeah, following the instructions. The E question told us, I guess I should do over here, so E question told us to look up R first, and then G. So this is, order's important. The C question says, go look up this G thing, because that's inside. So work from the inside out. Good question. Yes?
Do you think it could be like reverse?
Oh, that's, yeah, of course I can. Those are actually not too bad, but what you have to do is you have to look them up almost, well, not almost, you have to look them up backwards. So that's a good one, yes. Let me clear off all my chicken scratchings so it's a little clearer. How about, so let's look at B, this inverse. Good. So G inverse of 6. So what does an inverse do? It switches the X and the Y. So in this G inverse, is this 6, is it an X, or is it a Y actually? It's a Y. It's really a Y. So this is all we got to do is say, okay, go to where Y is equal to 6, and then I'm going to look up what is the X value. It's just, think of an inverse as I'm doing this backwards. So I go to 6 up here, not onto the x-axis, although that's usually what we do with functions, right? But an inverse just says you're doing it backwards. You're plugging in y and you're getting x. And then I go till I hit the g function. It's about there. And then I go down, and it must be about a 4.5. And just to kind of, and then let's go ahead and do D, same thing. G inverse of 3. So that says go to where y equals 3. Right, that's where that, emphasize it there. Go until I hit the graph of G, and again, and then I go down, it looks like, I don't know, 1.25. That's where it's nice having multiple choice. You'll get close enough, and maybe it's 1.3, but they're not going to give you 1.3 or 1.25. You can't tell the difference. I can't. So, but I'll just say, well, maybe about 1.25. Does that help? So it's an inverse lookup. Good. Good questions. All right. That's kind of what I liked about math, is a lot of times there's simple things, but understanding what you're supposed to do when those are not necessarily simple, right? It's a lot of different things going on. Do things graphically and with tables and with algebra. What was that? That was 12. So good look. I've got 9, 39, 49, and 26. So let's go to number 9. Okay, so these are ones looking at the domain. So when you see the word domain, what are we talking about? We're talking about what x's can we use that will give us a number, that will give us a value. Because there's some math we can do that is undefined, right? And there's, so far in this class, there's only two things that make things undefined. So when you see the word domain, there's only really two things we have to worry about. The first thing is division by 0. That's undefined, right? And the second thing is a negative inside of a square root. It's not undefined, but it's an imaginary number, and we're not including imaginary numbers in this course for right now. I think we do it later, but so we would say we can't put a number in for x that would give us a negative inside of a square root. So those are the only two things we have to worry about. So you see a domain question, what's the domain? Those are the only two things we have to worry about. If we don't have either one of those, we're scot-free. Then what? If not, then our domain is negative infinity to infinity. Basically, all real number, everything. We could put any number in, and we'll get another number out. So that's where we start, and then what we do is we look at the function. So this one, does this one have any potential problems? Do we have a square root? Yes, we do, so there's a potential problem. So we're going to look at that one. Do we have a denominator that could potentially be 0? Yes, we do. So we got two problems we got to deal with on this one. Which one do you want to do first? That one. Do you want to do the top or the bottom first? The top. That's the hard one. I don't know. They're both hard. Okay. So let's do the top. So what we're looking at is we've got the top has a square root of x minus 3. So what do we know? X minus 3 can't be negative, right? That means it has to be 0 or bigger. So we said this number, whatever it is, has to be greater than or equal to 0. Okay, that makes it a positive number. Is that okay? We solve for x, so it's not too hard. How do I solve for x? I forgot about all this stuff.
So you do positive 3.
I just add 3 to both sides, so not too bad. But again, knowing what we're doing, so x has to be greater than or equal to positive 3. If x was 2, it's not going to work, right? You can kind of look at that. We get a negative number. So that's part of our domain. Now we got to see about the denominator. So, but right now, what I would do with these is I kind of keep a number line, and I'll put my 0 here. What I know at this point that here's 3. 3 is included, so I'll put a solid dot, and then everything else goes this way, right? And I'll put my infinity here, my negative infinity here. So I'm kind of setting up that I know what it's going to look like. Yes?
Why is 3 included? That just makes the denominator 0?
Well, no, it's because it's in the numerator.
Yeah, numerator.
And it's okay, you can take the square root of 0.
Oh,
You just can't take the, so that's kind of the key part. Square roots we can have 0. The problem comes is if it were in the denominator, then we couldn't have it because, not because of square root, but because it was in the denominator. Good question. So then the only other thing we have to do now though is look at the denominator, what would make that equal to 0. And it's kind of a different approach. We're not actually getting what the domain is, we're getting what the domain isn't, right, when we solve this one. What we do is we take x minus 10, we set it equal to 0, and this is going to give us the value that x cannot be, the x that we've got to take out of the domain. So actually this is a probably good way to do this. So what do? Add 10 to both sides, just do the opposite. So if x equals 10, then we do get 0 in the denominator, and that's not a good thing, so let's not use 10. That's basically what this says. And so what we did is we come over to our number line, and we say, okay, here we're going to put a hole at 10. Okay. And so when I do this, it helps me write what this interval notation is going to look like. So 3 is included, so I get a bracket, right? Not a parentheses, a bracket. And I can go from 3 all the way to 10. 10 is not included because it's a hole in the graph. I want to take it out, so I use a parentheses. And then I have to use this little union, so I get to one side of 10, and then I got to hop over 10. And so then on the other side of 10, which looks like this, is there anything that's going to stop me after 10? No, I can go forever. Well, until I get tired, and I'll get tired before I get to forever, right? And that's our domain. Okay, so that one question had both parts, with division and square root. Yes. No, I do the number line because it's potential. It potentially could be that is what I'm always thinking, and then I'm narrowing it down. And since we did the numerator first, we found negative infinity got dropped off right at the start. And actually anything less than 3 just got dropped off. It doesn't exist anymore for us. Good question, though. Good question. So yeah, I always come to a domain question and say, oh, it's negative infinity to infinity. Now let me see what I really, what I have to exclude and where I go from there. This one, is just a square root, right? So 2a plus 7, what does it have to be? Whatever it is, it's got to be positive, can't be negative. So we say it's greater than or equal to 0. That's the way to define a positive. And then we solve it, right? Solve for a. So we subtract 7. And then you get 2a has to be greater than or equal to negative 7. Divide both sides by 2. So a has to be greater than or equal to negative 7/2. So no, and on this one, go up a little bit. This number line, here's negative 7/2. We have to be greater than that, so it's included, and it goes this way to positive infinity. Notice it is possible for the input, this case a or x, it is possible for the input to be negative. It's just that when it goes through by the time it's done inside, it has to become either 0 or bigger. And negative 2/7 will do that. By the time we're done, if you plug in negative 2/7, you get square root of 0, which does exist, but just square root of negative 0.001 does not. A little bit negative, and it's imaginary world. Okay, so that okay? So square roots are where we have, so anything about domain, just look for square roots, set them greater than or equal to 0, solve them. That gives you that gives you the domain directly. If you've got something that is in a denominator, you set it equal to 0. This one's a little bit more, so t squared minus 9, what would we do with that? Well, I guess there's 2 ways. You could go t squared minus 9. You could add 9 to both sides, right? So you get t squared equals 9. You could take the square root of both sides, but when you do that, what do you have to remember? When we take the square root, what do we get? We get a plus or minus, because when you square something, a negative becomes positive. So this is, yeah, we could do this. So t is equal to plus or minus 3. Okay, and again, remember that is what we have to take out, because if x is 3 or negative 3, we get a 0 in the denominator. And again, let me clear off some of the space, and I'll show you what that looks like, because that's a little funky. So what we found is negative 3 is excluded, positive 3 is excluded, everything else is included. Negative infinity to infinity. And I like doing this because actually this is my interval notation comes directly from here. Okay, this part that's included is going to go from negative infinity to negative 3. Close it off. 3 is not included. Then this little part in the middle, that's negative 3 to 3. Close it off. This part over here, that's going from 3 to infinity. And all I do is I use these little unions to say all of this together, but there's these two holes in the graph. So it's kind of like just two little holes, but it's the most complicated one to write. But if you use that number line, kind of, what's included, what's excluded, the interval notation will just sort of fall out of there. Is that good? How are we doing on time? We got till 7:45? 8:45. It's already 7:45, right?
Can you show us an example for undefined, like the negative square?
Say that.
Can you just look at an example of undefined number? You said like if we have a negative square, that means like.
Oh, in the square root?
Yeah.
Sure. Well, yeah, we could do this x minus 3. So what we're doing though is, well, if I put in, let me say 0, I get this, which then becomes a square root of negative 3. If you put that in your calculator, unless you have it set up to do imaginary, it'll tell you undefined. So that's the thing, is it's, or if you have it set up to imaginary, it'll give you, it'll use the little letter I, which is not a real number. So it's kind of like what we're trying to do when the domain question is, we're trying to avoid that. And so that's why we said it, that's why we went and said x minus 3 has to be greater than or equal to 0. Then we don't have to worry. What we're saying, anything less, as we did this, anything less than 3 would create undefined. And with these ones, if I plug in 10, that becomes, the whole thing becomes undefined. And once a part is undefined, the whole thing is. Now, I could put 10 up in the up here in the numerator, right? It's going to be fine. But when I put it in the denominator, we got division by 0, and once you've got even a part that's undefined, the whole thing's undefined.
Thank you.
You're welcome. Good. Okay. And remember, you still have, you can still use late passes, although again, it's best if you could, have whatever. I will be updating. What I'll do is I'll wait till this next weekend. I think I updated over the weekend. Did I? Okay. I sometimes don't remember what I did to what, because I got a couple. I'll update again after the exam. So this coming weekend, I'll be grading exams, updating things, and we'll see where we're at after that. So that was 9. Let's look up, let's go to 39. Oops. How did I get here? Oh. That was weird. Okay. 39. And it's not that I'm saying that these are the only ones, but certainly know these ones. And like this is a good one, but this one is already, there's a video on it, so I'll let you make use of your time there. 39. Oh, 39. This is good in general. One of these will be there. What I want you, now we won't ask you to do all the matching, but at least know one, and thing is we don't know which one we need. So how can we, let's just look at these, because there's these and they're going to match with these. How can we tell when the difference between a solid or a open dot and a solid dot? If we've got a solid dot, what do we know we have? It's included. We know we have either an equals or a greater than or equals or a less than or equals, depending upon which way it goes. But a solid dot means we've got a equals in there somewhere. So we can start to see, certainly, solid dot. So a solid dot has to have the equals. So B cannot be a solid dot. B is obviously an open dot. An open dot means not equals. You probably won't see that one. But then it would mean either just strictly greater than or strictly less than, no little equal to. Okay, so there's a part is look for the dots. If it's an open dot, it's not included, so that means there's no equal. Okay, if it's a closed dot, it means there has to be an equal on that side, right? Now let's talk about, there's sort of two main ones. There's, what's that? That is, I guess that's little I, and this is V, which is for 5, so this must be 1 to 5. So these two are similar. What is similar about these two? Sort of a big open hole in the middle. Okay, so what you're thinking about, especially with distance, what does this mean? This is like there's a paper mill. I used to live in Corvallis, Oregon. Albany had a paper mill. Does anyone live close to a paper mill? When the wind changes, you know there's a paper. There's a smell. It's a sulfur. It doesn't smell good. And most of the days was fine, but when the wind came from Albany towards Corvallis, oh, there's the paper mill. Okay, so maybe this is the one you want to live a certain distance away from that item. Okay, so notice these are distance away. So what is distance away? Both of these are going to be whatever we want to be greater than some number. So there's something inside here. We want this to be greater than or equal to 5 miles. We want to be 5 miles away from the paper mill. Okay, so that gives us an opening. So when you see this open middle, you're looking for a greater than. Now this one down here would be greater than or equal to. This one up here would be greater than, just greater than, right? Because it's got the open circles. So it's kind of helping us. And then what we can see is there's always a middle part, and this one has a middle part here. And then what's the distance? 1, 2, 3. So this has to be greater than 3. And then whatever's in here, you know, we're getting it narrowed down. It could be X. Okay, down here, what's the distance? Looks like it's going from 13 to 21. 13 to 21 is 8. So halfway between 8, so that'd be 4. I want to be 4 miles away from something. So this is going to be greater than 4. Some statement greater than 4. Okay, and so that kind of helps us see that this one has to march up with this one. And again, notice I didn't even go look at the x minus 17, but that's 17 would be the halfway point, and then 4 above and 4 below, but that's harder to see. Notice all I had to do is say, well, it's closed circles, so it's got to be a greater than or equal to. The space between them is 8, so it means halfway, 4 or greater. That I want to be 4 away. Okay, so that kind of makes sense. These two, I'll change color. Let's go to green. This one and this one, notice they're continuous in the middle. This means I don't want to travel a lot. I want to be within 5 miles of my school or 5 miles of my work. I don't want to do a lot of traveling, so I want to be close to something. So these ones, you're going to see are going to be less than, and both of them are open circles, so they'll both be just less than, right? Less than some distance. And again, we do the same thing as how long is this interval? It looks like it's going from 3.5 to 8.5, which is 5. What's half of 5? 2.5. So this should be a 2.5. Oh, there I see it. Something less than 2.5. Again, I don't get too much into this, but yeah, 6 is halfway there, so you could see it's 2.5 from 6. So you want to be within 2.5 miles of 6. So you can kind of spot it there. This one down here centered on 0, and we can see 1, 2, 3, 1, 2, 3. So this one, they want to be less than 3 miles from their sweetheart. And again, so I could say, oh, it's got to be this one. Nope, that's the wrong one. Less than. See? this one is the greater than, so that must go up here. Right, and the open circles. And if you just have dots with no spaces, then that's the equals, right? So it's just kind of, yeah. Is that helpful? So just the greater than, less than, just think, okay, it's a distance that's greater than. That means I want to be away from it, so I go like this. My thumbs are going like this. Get away from that smelly paper mill. If it's, did I say that right? If it's greater than, yeah. If it's less than, I want to be close to something, so they're connected and it's coming in. Okay. Interval notation. And again, in calculus, we use interval notation a lot as well. So that's mainly what this is doing for us. In reality, we don't use interval notation mathematically a lot. The only thing is this distance thing, but it also gives us a good understanding for solid dots, open dots, whether it's included, excluded, interval notation, all that kind of stuff. So that was 39, 49, and 26. And then which should take us pretty close to, oops, gotta switch back to here. 49. Why do I want to do 49? There we go. Okay, yeah. This one we may need some extra space, but let's see, I think we got a little bit here. We'll do this. Okay, so there is a question, and this was the last section we did, and so this is a difference quotient. So you're going to see something that says, ask for a difference quotient. What is the difference quotient? What is a quotient? It's division, so it's a fraction. So remember, it's this formula, f of x plus h minus f of x over h. What I also want you to remember is remember, where did this come from? This is just a slope formula from the 2 points. We have 2 points. One is x comma f of x. That's another way to write y. That's 1 point. The other point is x plus h comma f of x plus h. And because I want you, as we're doing this, to understand what we're doing here. We're setting, because this is we don't need to do this for algebra, first of all. It's a calculus. It's something you'll be doing you're probably, if you go to the engineering calculus, you'll be doing it probably your first 2 weeks. This is the definition they define to everything. So notice, remember when I introduced this one, in the denominator, there's 2 x values. So there's really x plus h minus x, but notice the positive x and the negative x cancel out, so they disappear. So when we talk about the difference quotient, you never see those x's in the denominator, but what it does is then you don't really see this as a slope. But it's just you're really subtracting the y's in the numerator, subtracting the x's in the denominator. And you just have to remember, we've got 1 point, which is x, f of x, and then we're inventing some other point that we take x and add some distance to it. That's what the h is. Is plus h gets us, it could be plus 2. And what we do in calculus is we say, okay, we're going to let h become 0, which means we're going to get the slope at a point. So that's pretty amazing stuff, mathematically anyway. So we're going to do that. So what we have to do is this green part is the difference quotient. So what they're going to ask us to do is take this function, and we're basically going to have to do 2 things. We're going to get 2 y values. We're going to get f of x plus h. And this is what I would say is sort of the hardest part of the whole thing, is we're going to take this function, x squared plus 3x. What do we do first? We change the x into a big open parentheses. So this is x squared plus 3x. x. What do we put into those open spaces? X plus h. X plus h. Okay, so that's what that f of x plus h now looks like, right? Once we go through, we're not done with it yet, but that's what's going to get plugged into this part here. And then we're going to subtract this function, f of x, which we've already got, right? So the thing is, what do I have to do with this, though? X plus h squared. What does that mean? Just FOIL, right? So be careful. I've seen something, okay, that means that's x squared plus h squared. But remember, there's a middle term here. This is x plus h times x plus h. Now this 3 we'll kind of do at the same time, right? We'll go over here. Oh, that's the easy part. That's just 3x plus 3h. I'll do that. But this one I've got to FOIL out, right? X squared plus xh, and then hx. So I'll write that as xh, and then h times h plus h squared. Okay. So if we combine it, x plus h plus x plus h, xh plus xh, this middle term becomes 2xh. And that's usually the part that gets left off if you're doing everything else. So what do we get? So this first one, f of x plus h, is x squared plus 2xh plus h squared plus 3x plus 3h. Notice how that's a long, it's messy. But the good news is we're going to subtract f of x, and you're going to see anything in f of x is going to cancel out. Because when you're subtracting f of x, there's a negative that's going to distribute. So all of these signs will change. So I'm going to get negative x squared. Oops, I'll do it up. Sorry. So I'll get negative x squared, negative 3x. That's the f of x, right? So here is f of x minus, and here is f of x plus h, all the green stuff. And that's all over h. Okay. X, we got a negative x squared and a positive x squared, right? So let's, I guess I'll just, so those will cancel each other out. I have a plus 3x and a minus 3x. Those cancel out. And so I end up with 2xh plus h squared plus 3h all over h. But am I done yet? Not quite. I can still simplify. Again, this will be a multiple choice one. That h in the denominator, I can distribute the division to each part. That's what you have to remember to do. So I can take an h out of here, divide an h out of there, divide an h out of there. So the h cancels here, so you get 2x. One of the h's cancels, so you get a plus h. And over here, the h cancels, so you get a plus 3. So for our good, we're done. When you get to calculus, you got to let h become 0, and it's okay. Now notice, would we have a problem if we let h become 0 like back here? Yes, we would, because it's division by 0. But after we simplify, it's okay. There's no problem with letting h be 0 at the end, because there's no division by 0. And what you've just done, actually, 2x plus 3, that's what's called the derivative. Okay, that's a thing we do in calculus. So we've actually done something that leads us to calculus, but it was, notice how much algebra was involved. And that's what you're going to see in calculus. The calculus step is actually the easy step. It's all the algebra that leads up to it. So it's what you're learning now that's going to prepare you for this. Questions on this? We okay? Again, it's tedious. There's only one question. That's a good thing. So if it's like I don't understand it all, sometimes you just have to say it's only 5 points. I'll pick it up somewhere else. Okay. That was, what was that? That was 49. I got one more, and then you guys tell us where we go from here. Let's see. So 26. Guess not a lot of time left after. Yeah, see, I knew we wouldn't. We'd be short on time. What did I say? 26. 26 is a good one. This one, I didn't really. Just to let you know, it's a little. The one there's something similar like this on the test. It's the one on the test is more simplified, but understanding these steps of what we do, you'll definitely be able to do the one on the test. Okay, so we've got this diagram. We've got a circle with a square inside. We've got a radius. We're given the formulas for the area of the circle, area of the square. Circumference and the side of a square in terms of r. So determine a formula which expresses the area of the circle in terms of the length s of the side of the square. So determine a formula that expresses the area of the circle. So where do we want to start? The formula for the area of a circle. Area of a circle is pi r squared. But they want it in terms of, so what does that mean? They want the variable to be s. Do we see an s over here? No, it's an r. So we've got to get r in terms of s, and let's see. How could we do that? Side of square. So this formula here really is s equals square root of 2r. Okay. So we want to be able to put something, we want this r, we want to find what r equals in terms of f's now, right? So what do we need to do with this formula here to solve for r? Divide by square root of 2, right? So this cancels. So that gives us r equals s over square root of 2. So again, we figured out we want something in terms of s. So our formula currently has something in terms of r, so we need to find what r is, and then now we can, what can we do with s over square root of 2? It's saying it's the same thing as r. So we can change this r, right, into s over square root of 2. And that's it. We now have the area in terms of the variable s. Now, this is fine to leave it this way. However, we could do some simplifying, right, because we could square. And so it might be written as this becomes s squared. So you might see pi s squared over 2. Square root of 2 squared is 2. So and again, it's more simplified than this, but they might simplify a little bit. That could be, again, a multiple choice. You just have to be able to recognize the correct answers. Both of those are correct answers, this one, so I could box them both. If it was an open answer, that's where sometimes they're easier. I could leave it like this, and this is a correct answer. But multiple choice, somebody else is choosing which form to give it to us in. So we just have to be able to recognize, oh, these are equivalent. I came up with this, but they took another step and did some algebra. Okay. So just recognize it. Determine a formula that expresses the circumference C of the circle in terms of the length S of the side of the square. Okay, so basically the same thing, except we start with the circumference. Circumference equals to 2 pi r. And we want it in terms of S. Well, we've already done the heavy lifting. We know we just need to substitute in for r. So circumference equals 2 pi S over square root of 2. And that's not really going to simplify much. I mean, it might look like 2 pi S over square root of 2. But that's about, is that okay? So again, just kind of thinking that's in terms of means they want that to be the input variable. So we're going to be given enough equations and we have to solve one for the variable that we're trying to replace. Okay, so notice I had to know, okay, I've got this r and they want s, so I've got to find an equation that has r related to s, and then I have to solve it for r so I can plug it in. And then you can go through the rest, but that's what you'll need to be able to do. 26. Questions on that? You okay? Again, just practice. Don't stay up too late on Wednesday. Make sure you get some sleep. That's one of the most important things. Of course, don't tell me that, because when you tell me, I'm afraid I'm not going to wake up, so I wake up every hour. And no, go ahead.
So you said there's 25 questions on the test.
20, only 20.
Is each question gonna have A, B, C, or is it just one E?
Has A, B, C, D, E. Each one has, so there's 5 choice. So you have a, randomly guessing, you'll have a 20% guess on it, but you'll do better than that. You'll, like most of them, you should probably be able to get them down to at least 2 by process of elimination, and with some of the things we've done. And then if you have to guess, it's a 50-50 chance on each one, but you'll get it down to at least that. But I think, and remember, this is just, part of it is this is, I think, the hardest test because it's the first time you're seeing it. The next test, you'll be used to the way the tests go, and then the final. And remember, if you don't do well, so this is the main thing to tell yourself to reduce the stress. If you don't do well, when you do the final, you will do better and will replace whatever you do on the, so what they do is they divide the final up into the 3 tests, however many we take. And they say, okay, this one, these questions represent the questions from the first test. They're similar. So we will get you a separate score for each part. And if on one of them you get to replace 1 grade, if it's lower the first time you took it, if the final's higher, we get to replace that. And it works for either 1, 2, or 3. So yeah, if you do well, then you can say, okay, I've got my marker. Maybe the next test I don't do well on, I got that. As long as I learn it by the final, that's kind of what we're looking at. Because that's what we, sometimes, learning, there's this struggle period and you don't understand, and then all of a sudden at the end you understand. So we do that to capture what are you understanding at the end of the course. And if you're understanding at the end of the course, we're not gonna average it. We're just gonna give you understand, right? And then, because then you're gonna be successful in calculus. That's our goal. So just kind of take it with, prepare yourself, think about what you're doing. But do it as an experience. It's just, if it doesn't work out well, you still learn something from it. You learned, okay, next time I'm going to do some things a little different. This, and this. I'm going to get the homework done sooner. I'm going to be on track with that because I got a little bit behind in my other class. That's a lot of this stuff is learning, and we give you that space to do it and that safety net. Okay. Anything else? Okay. You're welcome to hang out a bit and work if you'd like. We got 10 minutes before the next class comes. Do we have a class right after this? I don't know if anyone, I think oh, that's right. They do start kicking us out. Anyway, prepare well. I'll be here a little early Thursday, and we'll start passing things out. We'll get you started right into the test. You take the test. When you're done, you're done.
I had some technical